Hello and welcome. Now that was funny. It didn't even make a sound when I started it. Brand new camera. Brand new Canon 4K. We sent that baloney Sony back and we picked this one up. This is the SX70. Now my other one's an SX20. It's an old timer. This one has a mic input, which is nice. I'm using the headset. Now, last time somebody said it was a little bit loud, so I've moved the microphone further away. And so I'm hoping the audio is okay. And we'll get on with it here, I guess. Today on the bench, we have a 1946 Packard Car Radio customer sent in. And it's been sitting here for about a week. I've been busy, but still busy. But I figured I better get on this. Even though he said he was in no hurry for it, it feels like a weight hanging over my head when I know I got a customer set sitting here. This is how it came out of the box. And the bezel looks a little bit rough here, but the only part that shows is from here to here. It's the only part that sticks through the dashboard. The rest of this is behind the dashboard, except for the knobs, of course. So we'll see how that cleans up when the time comes. This surface looks savable. We'll clean everything up. I did notice when I took it out of the box, there was something rattling around inside. Haven't opened it up yet. We'll do that together here on the bench. I hope it's not a broken tube. These do have loctals in them, so they should stay in the socket. Well, they're supposed to. And looking this girl over, she hasn't been touched in a long time. Excuse me, long time. Just had some chicken tikka masala for lunch. Stuff is great. All of the screw heads have rust on them that has not been disturbed in a dog's life, so I think she's a virgin, so we'll be gentle. And we'll take off the two screws here on the back, or yeah, I guess this is the back. This part of the radio sits behind a great big chrome grill, and all you see in the car. For those of you who remember the old cars, you always had this great big huge speaker grill right in the middle of the dashboard. Yeah, those haven't been disturbed in a long time. I'm flaking all the rust off of them, so we'll be seeing this together for the first time in a long time. Who knows? This may not have been opened up since it was manufactured. Hard to say. Let's see what we find inside. Look at the size of that power cable. These sets drew a lot of current at 6 volts. All the vacuum tubes and the vibrator circuitry. Actually, I'm not going to do that. These knobs are already cracked. They came in cracked that way. Now they're not falling apart, but he did tell me he's got, I think he said he had 3 more sets, or maybe it was 2 more sets, and this one's a total of 3. So he's got extra parts to work with. And everything else here should be okay as we slip the back off and see what we find inside. Oop, yeah, you can hear whatever that is rolling around. I'm probably going to have to pry this off. She hasn't been off in a long time. Oh, it moved. It moved. PA, is that the same number? P39255. Different number. This is manufactured for Packard Motor Car Company on the bottom. I believe these were made by Philco. And is that what it says here? Yeah, Philco model P4635 or model PA. Yeah, that's the right model number. Serial numbers on the main chassis inside, and they got a cutout on the outer case here so you can see it. I'm going to have to grab a screwdriver. We'll be right back. Okay, we've got a slot right here for the screwdriver, but it's not working out. We'll just do it on the edges here carefully. Work it up. There we go. No, it's got the schematic inside. Push-pull output audio. Philco radio model. Yeah, it's got Philco tags on the inside as well. Let's tip this up. Oh, yeah. Not only are Lockville sockets horror shows from the corrosion that affects them, they don't do their intended job very well. Tube got knocked out. She's got old paper caps there that I can see. Now, before we put any juice to this, we have to go in and change a couple of key components. Let's see if we can get that lined up. There we go. Back in her socket. At least it didn't get broken. Now, he did send along a complete set of tubes for this. Don't know that we're going to need any of them. Typically on sets like this, when they've been sitting for a long time, most of the tubes are usually good. Tubes are usually one of the last things that fail over time. Not that they didn't fail in service, but when they sit for, 40 years, they're just as good. If they were good when they were put away, they're usually just as good 40 years later. It's the capacitors and the resistors that suffer from time. And like most car radios, this thing's going to be a horror show to work on. Let's see if we can get the front cover off of this. We got one. Yes, this will take the speaker off as well. All right, I'm going to pull out a bunch of screws. Won't bore you with that. I'll be back when this cover's off. Okay, we got the screws out. Let's see what goodies are hidden inside. Ooh, that's a heavy speaker. And it's got a field coil. Now, these sets, the field coil is not used as a filter choke like it is in the AC or even the AC battery sets. This is directly off of the 6-volt battery. It just energizes that coil. So there's another thing, drawing current. You didn't go parking with your best girl with one of these sets running unless the engine was running, because 20 minutes later you'd be walking home. And hello, test. Yeah, okay, the microphone's working. These things drew a lot of current. You can, from evidence just by that power wire, power lead. 2 dial lamps. But a concern with these sets, one of my big concerns is what kind of shape is the speaker in? And that's what I was afraid of. The coil's dragging. Finding a replacement for this, he said he has 2 more sets. So if we get the set working, maybe you get lucky and find out one of the speakers in the other set is okay. Let me get the nuts off of here and take a look at the cone. I got to get another nut driver. Okay, I went outside to talk to the postman, and when I came back in, I forgot to turn the wireless microphone back on and just hit the go button on the camera. What I'm saying here is there's a split in the cone, and there's a bubbled area right where the split is, where obviously this thing got a little bit wet at one time. And the voice coil is dragging on the pole piece, but I found that if I moved it up and down a few times, it dragged a little bit less. So I think it was a combination of being off center and some rust on the pole piece. And I've discovered if I push the cone over in the direction of the split, it stops rubbing. So we'll do some experimenting with that, see what we can do. Worst case, we'll replace this with a permanent magnet speaker. We don't need the field coil. In fact, it'll reduce the current draw on the set if we took the field coil, disconnected it. Or I can see if he has a good speaker in one of his other radios. There's a possibility one of the other spares he has a good speaker in it, that the voice coil's not dragging. But I was expecting it to drag. They are almost always dragging when they've been subjected to moisture and laying around in a car that's been unused for so long. It's, you know, it's just comes with age, and it comes with being exposed to the elements. So I'm going to put some liquid electrical tape on that split. We'll stop the two edges from vibrating, and maybe it'll help shrink it up a little bit on that side, and we'll carry on from there. So that's the story on this clip. The next clip will be back to normal recording with the camera microphone. Okay, the liquid electrical tape dried over there, and then I took this very soft brush and started working the dirt off of this. And we have another split over here that was hiding underneath the dirt that had accumulated from the speaker. You know, sitting in the set for so many years, everything accumulates down one end, and that was hiding underneath quite a layer of dirt. But you've got to be extremely careful with these cones are so fragile after all of these years. Now, I don't know if you'll be able to pick this up on the camera microphone or not, but you can hear it drag. Well, it's not bad now. Right there. If I touch here, it definitely drags. If I touch here, there's no drag at all. I'm influencing the cone in that direction ever so slightly. But it's blistered in here. It's blistered here, and that's water damage. And again, like I said in the last part of the video, it's not surprising after all these years. Right there, it's quiet. But yeah, if I could just influence the cone in that direction. But this is very firmly glued down. We'll see what we can do with it. There's little tricks that sometimes work. Sometimes you can wet an area and then quickly dry it, and it shrinks the paper. But I don't want to do that until I find out if the set's viable. So I'm going to put this. Actually, I'll put some more liquid electrical tape here on this other tear that I just found. And it's not a very big one, but we don't want it to grow. And it's just that this paper is so old and so fragile. So we'll let that dry. And that's flexible, so it'll move with the cone after it's dried and not affect the sound at all. This is a common fix that I've been doing this for years. We're going to put this back on its plate for the time being, just to keep the thing safe. And look at the stuff that's in here. I don't know if you can... all kinds of stuff was accumulated down here. There was a ton of it. We'll clean this all up. We're going to try to preserve this rubber because that's the seal that goes against the grill, the chrome grill that's in the front of the radio. But we'll mask it off, and before I'm done here, I'll give it a little light spray of Rust-Oleum just to cover up the bare spots. We'll clean it up and help stop the deterioration. You can't see any of this when it's in the radio. You know, the only thing that sticks through with the knobs. This is completely hidden behind the chrome piece, but it'll help slow down the deterioration and the rusting. Yeah, we've got some rust along here. I should sand that down and give it some clear, just to preserve it. The tuning mechanism is very dry and stiff. We'll clean that up and get it going. But the first thing we're going to do is change some capacitors and make sure the set is viable. So let me get the speaker mounted back up and we'll move on, and I'll show you on the schematic what I'm going to do. In order to, boy, it's disconcerting. I push the record button and nothing happens. There's no sound. I'm used to getting some feedback. I'm going to disconnect the speaker. It's hardwired in. Now the speaker does have these terminals here that are actually designed to have the little push-in pins, but evidently as a cost-cutting measure they just went ahead and soldered. You know, it was right after the war, 46, so metal may have been in short supply still for those extra goodies. Just put a brand new fresh homemade tip on my soldering iron here. For those who don't watch regularly and don't know, that's number 12 house wire. Don't spend your money on Weller tips. It's a waste of money. You can take leftover hunks of wire and make hundreds of tips, and they work just as good as the factory ones. We're going to remove these wires. I can't tip it down enough to show you what I'm doing and have enough room to work. I mean, you know, have enough wire to work for the angle. So I'm just going to desolder this real quick. It's just 3 wires. And then we'll get the schematic out and show you what I'm going after. Come on. One up. There we go. I should have got the heavier duty gun. If you've got the higher wattage one, this is the 100, 140. If you've got the bigger one, which is what, 240 watts or something, use number 10 house wire. But for this one, you want number 12. So that's disconnected. It's real easy. We got black, brown, and this one's green. I just put G, brown, and BK for black there. But the 2 of the wires colors are already there, so it's almost impossible to screw it up. Big hunk of rosin. Okay, what we're going to do, let me get this cleaned up. A lot of dirt came out of here, and let me get some stuff cleaned up first. Well, that was an interesting detour. As I was getting ready to go in here, I pushed a couple of the buttons and the dial wasn't behaving correctly, and I looked down inside and I could see this piece at an angle dragging on the indicator, and it's held together with these little clips. Well, there's only one on this, and then this piece fell out. When I took it out, this goes down in here. There's supposed to be another one here, another clip here, and it's missing, which is kind of interesting. And then I discovered there's this little color wheel here, I guess it's in frame, that's in front of the dial light, and this is a light pipe as well as being your dial indicator. It's got a light pipe to pick up the different colors. So I'm guessing that the tone control changes the color of the backlight as you're changing the tone level, which is something I've never seen before. But fortunately, I've got a whole box of these little clips. And while I'm in here, I might as well clean it up. The little felt piece that's in here is deteriorating, falling apart, so I'll copy that. I'll burn a new one off on my laser, and we'll replace this piece as well. It's like a little dust shield that goes in here, and that'll help keep the dust out of the mechanism. So I'll measure that thing up, and we'll burn up a new one on the laser, and I might as well clean the mechanism while I'm in here. But I'm going to take care of that, and I'll show you bits and pieces as we go. I'll put some fresh black paint on that piece and see where it takes us. It's funny, you start off to do something and you look in, you spot something, and it just takes you off in a whole different direction. We'll put some new number 47s in there while we're at it, so it's got fresh dial lamps. And then we'll put the tuning mechanism back together after we clean some of the crud out and give it a little bit of lubrication. Okay, we had to take this off because the dial pointer was crashing into this piece, and it had to come apart. It's got to come apart anyway. This whole mechanism's got to be taken apart. But I cleaned up this front surface. Now this, you know, the water stayed in there for a long time, but this part of it from here to here didn't come out too bad. There's some very minor pitting. Nothing you can do about it except replate it, and that's becoming a more and more difficult task these days. Plating houses are being shut down because they don't meet EPA standards. In fact, I think in the UK they're not even allowed to do any chrome plating anymore. You have to buy from somewhere else. The motorcycle and auto restorers in the UK are in a tight pickle because they can't get stuff re-chromed anymore, I believe. At least that's what I heard a year ago. I saw a video where the guy was bemoaning the fact that he can't get parts anymore or get them chromed anymore. So that didn't come out too bad. That's cleaned up. Now this was the either dust cover or light mask. I'm not sure. It might be to keep the light from coming through as well. But that's had it. That's shot. So I put that in my flatbed scanner, and this is what it looked like initially. And this is what it looked like after 15-20 minutes using Paint Shop Pro to clean it up. And again, here's what it was. Here's what it is. Then I put that in the laser, and I did a burn. I did a test burn. This is cardboard from a cereal box. I think this one was Rice Krispies. And set it on here, and it's a little bit short. Now when you go from a scan into Paint Shop and then import that into the laser, the scaling isn't always perfect. That's why I do a test burn. So I just stretched it out a little bit. Took seconds just to stretch it out in the software. And this one slips right over. That one fits beautifully. So then I took some felt and burned a couple of them actually out of felt to put on there. Now the problem is this isn't real felt. This is a PEA or PE, not PET. It's a plastic. It's a woven plastic, and it doesn't cut real cleanly. If you cut it with scissors, it doesn't look bad, but when you try to do something like this in a laser, it melts its way through. And it leaves the edges a little ragged. Now you won't see that at all. It'll be completely hidden when this is on top of it. But I've ordered some 100% felt sheets because I want to make felt washers for the old antique radios. I've made them out of this before. And again, they're hidden behind the knobs, but it's just, I just don't like the way they look. So I've got some real 100% wool felt on the way, and we'll cut some out of the real felt. But I've got the program now. The dimensions are all right. It's just a matter of dropping the felt in and pushing go. But there's a trick. If you're running a laser, you know, save your old cereal boxes. They make a great medium for doing test burns, and it's free after you eat the cereal. So that will go back together with that. We'll take care of that when the time comes. The next problem is going to be, I have to fix this mechanism. Now this side, let's see, make sure we're in the correct frame. Oh, and I didn't turn on the backlights. I tell you, you get out of the swing of doing this for 6 months. And, let's see how much better it looks with the backlights on. Probably fix it up a lot. All right. When you push the button, it's supposed to tune the radio, and that one worked. Kinda. That one worked. That one worked. That worked. That one sticks. What did you see it swing back? And when I push this one, it goes over to the next station. When I push this one, oh, that time it worked. That time it didn't work. It didn't latch correctly. There's a little bar with hooks on it down there that grab these. and when you push them in, it's supposed to release the button next to it. That time it worked. It released correctly and it latched over here. But that time it worked. That time it worked. And it's loosening up a little bit the more I do this. But I'm just, they're hard to push. They're sticky. And the only way to yeah, see, that didn't want to go in at all. The only way to fix this is to take this mechanism out and flip it over now. I'm a nervous wreck about doing this because these cars are 1946, first year after the war, first manufactured year after the war, and I don't think there's all that many of them left. And even though Matt said he's got extra parts, I'd rather not have to dig into the dwindling supply of spares. But what we're going to do, oh, look at this, manufacturing defect. Nobody's been in this radio to the best of my knowledge. Anything that's in here is from the factory. This wire's melted, and this dial light right here, I bet it was when they soldered this in at the factory, because this goes in, then this goes in, and then they solder the wires here, 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 and a few other places. They solder all of this stuff in after the fact, because these are two separate assemblies that get put in the frame here at the factory. And when they went in here to solder that, the guy must have brushed his soldering iron right here. It happens. But I've got to pull this mechanism out and get that working smoothly. Let's see what we've got here. I've got, well, these two screws hold the front cover on, but they're also in the frame for the, are we in frame? Yeah, we're looking good. They're also in the frame for the push buttons. When you take these screws out, you've got to pay attention. There's different types. The ones in the tight clearance areas here are kind of a flat head, whereas the ones on the side have a domed head. So they are different, and they're a different thread as well. You got to be careful what you stick where. But that's funny. Somebody at the factory scuffed the insulation with their soldering iron, evidently. Whoa, that's coming out hard. Is that rusty? Oh no. Another factory defect. See how shiny the threads are? Somebody cross-threaded that, or they didn't, it wasn't tapped well when it went together. And that's a different length. You got two different lengths here, so you got to keep track of that. That probably is a shorter one, so it doesn't drive it into the potentiometer for the off and on switch. So we'll have to keep track of that. There's a lot of gotchas in these sets. That one looks alright. And that one looks alright. So 1, 2, 3. Got to try to remember the sequence here. And some interesting things. This is the back that goes behind here and illuminates it like the shadow mask for the dial. But it's got this piece of, what do they call this? They had a name for this plastic. Oh, I wish I could remember now. They use it a lot in theater lighting. There's a name for it. The lamp that's over here, I noticed, that I took off of this side, there's plastic in here of the same color, this purplish color. So this dial wasn't white backlit, it was kind of bluish light backlit. However, this lamp over here doesn't have that mask on it. This one's just bare glass, because this one back illuminates this color wheel when you turn the tone control. Oh, my hand's in the way. So when this color wheel turns, the light pipe picks it up and it'll shift the color in the front dial. And when this is on the dark one, turned all the way down, so the dark one's presented here and it isn't illuminating it, you'll have the blue light, and then as you turn it up, you'd have a yellow and then a red. So I'm curious to see what that's going to look like after it's all back together. I have to paint this piece. I got to back the camera up a little bit here, get everything in frame. I've got to paint this piece flat black. Well, the paint is flaking off of it, so we'll clean that up and paint it before we put it back together and get that done. Now, I want to try to keep track of where these screws go. Ay. So many pieces and parts here. And it's going to get even worse when I start taking the... I guess I can disconnect all the wiring, but I don't want to. I want to try to disturb as little as possible. Got to be careful. There's a coil here, antenna coil. Oh, another thing I'm going to have to watch out for. These say mica mold, but this is a end of war radio, right at the end of World War II. And it used to be, when I saw a mica, or I saw a mica mold cap in there, I'd ignore it because it's a mica cap and they almost never failed. Very seldom. And there's some more in here. There's another mica mold and another one up here. This one's a bypass cap up on the top of the chassis here. Yeah, we've got one up here, one here. These are all going to have to be tested because during the war, mica was a strategic war material, and being a strategic war material, it was limited as to who could use it for what. And even in the military equipment, if you watched my video on the frequency meter, BC 225, 224, something like that, I can't remember, I did a video and I showed this advertising from the war, and you can see they were making molded paper capacitors that look just like the mica capacitors. And it actually bit me in the butt because I powered up that frequency meter thinking there was nothing in there but mica caps, and one of them split open and blew out a ton of smoke. And when I cut it open, it was a paper capacitor, molded paper cap. And there was a couple of others in there as well that were just leaky as sin. They had to be changed. So I'm going to have to test these when I'm changing out all these waxy paper ones. I'm going to have to lift a leg. This is a bypass cap, so I wouldn't be surprised to find out that that's paper. Let's see which tube here is the oscillator. There's the IF. So this might be the oscillator. This might be part of the oscillator circuit. Chances are, if it is, oh, there's two caps here. One, if it's in the oscillator circuit, it might be a mica cap because they want the stability for the oscillator. But it wouldn't surprise me at all if the rest of them, or even all of them, were paper capacitors that were left over from war stock. And of course, they'd be using up all that inventory in civilian building until it was gone. Okay, I am going to carefully, I can't lift this enough to get underneath it. It's going to have to come out. So I'm going to try, still trying to make up my mind how I want to do this. Do I want to take them both out? Well, I'm going to have to desolder here no matter what, because that's mounted to the frame with rivets, as is the antenna connection mounted to the frame with rivets. I think my safest bet is to carefully desolder these connections, and I'll slide this guy out so I don't disturb any more than I have to. I really don't want to take those solder connections apart, but I don't see any way around it. If I try to take it out, it's 2 units. I'm too much of a chance of breaking something. Okay, I'm not going to bore you with all the desoldering work. So when we get it out, I'll flip this mechanism over and show you what's underneath. Okay, before we get distracted again, before I go any further with tearing that tuner out or doing anything else, I've got to make sure this set works, or at least is viable for working before we put a lot more time into it. Everything I've done up to now would be applicable for one of the other radios, you know, that I could just transfer parts over. But before I go crazy, I want to make sure this one runs, or if it doesn't run after recapping, then I know it's me, and not that the radio had an inherent problem to begin with. So immediately we have to check these filter caps. We've got 3 of them here rated at 300 volts and 1 rated at 25. This is a cathode bypass for the output. I already know the answer to that because I just looked on a visual inspection, and I can see it's leaking its precious bodily fluids out the bottom. So we'll give it a test, but I'm pretty sure we're going to find it's a resistor and not a capacitor at this point. So that has to be checked. Before we power it up, we have to change this capacitor. This is a 1600 volt capacitor that absorbs spikes across the secondary of the power transformer that are produced by the vibrator power supply. And if this cap is bad, it loads down the transformer and it loads down the vibrator. The capacitor that's over here, they're bypass noise caps. That's not a big deal at this point, but that one's a crucial one. We've got to change that. I guarantee that's leaking. I've got some 1600 volt caps I purchased just for that purpose. Actually, I think the ones I have are almost 2000 volt. But anyway, then we have to come over here. Let's see if I can get everything in frame correctly. Got an interesting circuit here. We have our IF, then we have our detector and like an audio preamplifier here. This is our first audio. Then it goes into an inverter. This tube is used as an inverter, and the reason there's an inverter is if you follow these 2 lines down, you have a push-pull audio output down here. Let's try to make sure everything stays in frame. Which means because you're going back and forth to the opposite sides of the output transformer, these tubes have to conduct back and forth. They have to flip-flop so that they're feeding alternate signals back across here. Well, that's done by taking one of the grid signals from the anode and one of them from this cathode, and if you follow that down, you can find it comes down, and one tube is fed, the grid is fed from the signal from the anode, and the other one's fed from the grid, or excuse me, the cathode to this grid. And they have a fairly high cathode resistor, so that cathode has a fair amount of voltage swing, just like the anode will. And they use that to invert the signal so that it alternates back and forth to this Class B or Class AB amplifier here, where the tube's only conducting on the positive part of the cycle, and it cuts off shortly after it transitions 0, and then the other tube takes over. So we'll have to change, we've got a bypass cap. I'm not going to worry about that too much. But we've got a blocking capacitor here that we have to make sure is changed before we power this up, otherwise we end up feeding anode voltage onto the control grid of that tube, and it drives it into regions it's not supposed to be anywhere near. It's going to just, it's bad for the tube, let's put it that way. And the other one has a blocking capacitor here. That'll have to be changed if we follow it up. I'm trying to make sure I'm close enough to the schematic here so that it's readable on the screen, but it limits my field of view, or your field of view. Yeah, that might be better. So this cap, that cap have to be changed. These are going to have to be changed before we fire it up. And this one will have to be changed. There's nothing else in here that I see that worries me at the moment. There's going to be leaky caps everywhere. They're all going to be bad. In fact, most of them have started oozing their guts out. But the only ones that are going to cause us harm at this point is this one, these three, and this one. I'm hoping the vibrator works. I still haven't located. I know I bought more than one vibrator unit when I bought the one for Tom's radio. I had another one I bought at the same time, and they operate anything from 2 volts to 24 volts. So that's the solid state units that replace this mechanical vibrator right here. In fact, those of you not familiar with a vibrator system, I printed a different schematic here that shows it a little bit clearer. And what it is you have an electromagnet. Your 6 volts comes in, goes to the center tap of your transformer, primary, your power transformer. And then one leg goes to this contact, the other leg goes to this contact, goes through this reed, through here, through this electromagnet, and to ground. And or excuse me, it goes through this ground, goes through here, goes through this contact, energizes this electromagnet to ground, and this one comes through here and goes to ground. When you power it up, the electromagnet swings this reed up, breaks this contact, makes this contact. Of course, when that happens, the magnetic field goes away, so the reed swings back down, hits these two contacts, triggers this side of the coil, fires our solenoid, our electromagnet, flings the reed the other direction, breaks these two contacts, and it makes that one, and it just sits there and hums. That's why they call it a vibrator. It buzzes the whole time it's running. And most of the cars that I drove when I was a kid had radios with these in it. And as they got faulty and we were poor, you know, just dumb kids driving around, you just used to reach over and give an almighty kick to the dashboard to shake the reed loose a little bit, and they'd usually take off and run again, and the radio would play. Let's see what else. I guess that's about it. Oh, I was talking about the field coil earlier. Here's your main power switch, and we got an arrow here that says F. Well, that comes out over here, and here's your field coil on the speaker for your electrodynamic speaker. F goes in here and it goes directly to ground. So when you turn the radio on, this is shunted directly across the 6 volt battery or across the 6 volt supply to provide the magnetic field for the speaker to operate. There's no permanent magnet in these. If I end up having to replace that speaker, it would probably be a good idea to do it with a permanent magnet speaker, eliminate this field coil, eliminate 2 amps of current draw, because this is absolutely not needed for the radio to function other than to make a magnetic field for that electrodynamic speaker. And that's that great big coil that's right here on the back of the speaker. That's an electromagnet. That's all that is, because they didn't have nice neodymium magnets back then. I'm going to have to go over to the other bench to do the filter capacitor test. And I know it's a waste of time because I know it's going to fail, but we'll do it anyway. And then I'll have to come back here. The reason I got to come back here is my 20 amp 6 volt supply is the thing up there with the 2 meters on it, and it's wired into this patch panel that you see down here with the red and the black test lead hanging off of it. That power supply is about 80 pounds and it's 18 inches deep. It won't fit on the bench or on the rack over there at the other workbench. So it has found a home there until I am underground somewhere, and it's going to be somebody else's problem to move it. But that's the supply I need to run the radio, so I'll be coming back here. But the high voltage test setup for the filter caps is over at the other workbench, over at the $10 test bench. So let's walk over there real quick, and then we'll wrap this up, because we're up over half an hour already. I don't want this thing to run on too long. It's going to be a long video in pieces. Okay, and once again, excuse the camera shake, I know that I'm wasting my time here testing this cap, but for those who aren't familiar with it, what I've got here is it's just a box with a light bulb and a switch where I can apply voltage to these probes through this lamp, and then it's got a neutral position where I can wait, and then a discharge position where the charged capacitor will discharge through this lamp. And what this does is show me if I have a good cap or a shorted cap or an open cap. Now I'm going to go up with nothing connected to it, and if I go and it's fed by a DC power supply up here, 125 volts DC. That from that Heathkit supply. That's just to provide some test current. Most of your filter caps and your All-American 5s are going to be around 125 volts. They run at line voltage, and then this is usable, you know, for any other capacitor above that voltage. You're just testing them at a lower 125 volts. But at any rate, if the capacitor was open, when I flip this switch up, you'll see nothing on the light, nothing at all. So you know that capacitor is not, you know, connected to anything. Now, if it was shorted, dead short, you get that. The light just stays on. That's a dead short. Now, a good capacitor, which is what this is a brand new one, you will see the charge cycle. So when I flip it up, you'll see it charge, and then the light goes out as it charges. See how quick that went? That charged almost instantly. Then I'll go to the neutral position and then discharge, and you see the flash again. That's the capacitor discharging through the lamp. Charge, discharge. That tells me that's an extremely healthy capacitor. Alright, and it safely discharges the cap for you. So we'll hook it up over here in the radio. And again, I know these caps, this cap is bad, it's leaking out, but I just want to see how bad it is. Okay, let's see what happens. See the steady light? We're leaking voltage to ground. And if I go the other way, there's nothing at all. When I go from here to test, there's no flash at all, so it's not holding any voltage. It's leaking so badly it just instantly self-discharges. If I was to turn this set on and try to run it, I'd be dragging the power supply down, because it simply is a resistor at this point. I'd just be loading it. Same thing with this section. It's just a dim light, no charge discharge cycle whatsoever. So that filter cap has to be changed before we go any farther, along with those two coupling caps and the 1500 volt cap, which is probably this one. I'm going to guess it's that one, but I'll have to look at the schematic and see where it's wired in. But the vibrator, oh, out of frame, the vibrator's here, so this is probably the 1500 volt cap. Oh no, let's see, the vibrator, power transformer, maybe this is it. Maybe this is the 1500 volt. I'm going to have to take a look at the schematic and see which one's where. Yeah, this has got to be it. Now we got to test, we got to replace all these waxy paper ones after, when we know the radio is working, and then we'll test all of these for leakage and find out if they're paper caps or actually mica caps. Okay, that's it. I know this one's dragged on and we haven't made a lot of progress. I've been trying to get my computer fixed. I've been trying to... I've had trees to cut down. Just all kinds of stuff going on. 6 months worth of backed up work. I'm the radio mechanic. We're going to try to keep going at this for you. And the next one, when you see this radio again, I'll at least have the filter capacitor replaced and those 2 other caps. And we'll see if we can bring this set up and make it play. Stay well. See you soon.